What is branch current method? The first and most straightforward network analysis technique is the branch current method. In this method, we assume the direction of currents in the network, then we write the equations describing their relationship to each other through Kirchhoff's current law or voltage law and Ohm's law. Once we have one equation for every unknown current, we can solve the simultaneous equations and determine all currents and therefore our voltage drop in the networks. Let's use this circuit to illustrate the method. This circuit consisting of a battery with 28 volt supply, resistance with 4 ohms, resistance R2 with 2 ohms, resistance R3 with 1 ohm and the battery B2 with 7 volts. So the first step is to choose a node. Node in the sense junction. Here I have chosen a junction which is right to the R1, top of R2, left to the R3. After choosing this node, guess the direction of the currents. What are the currents that are coming into this node and what are the currents that are going to into this node? You can label the currents according to your convention. Whether the convention may be correct or wrong, that can be finally chosen at the end of the circuit. So here I have chosen a node. From this node, I am assuming the current entering I2 and the currents I1 and I3 are leaving. So the entering current I am taking as positive and the leaving current I am taking as negative. I am first write the equation, that is minus I1 plus I2 minus I3 is equal to 0 by using Kirchhoff's current law. Kirchhoff current law states that the sum of incoming currents and the outgoing currents is equal to 0. So once you've done this, then specify the conventions. So for battery plus minus convention is already there. For this one, since the current is entering, so minus plus, this is also minus plus. The current is leaving here, this is plus minus. So after given the conventions, you just go with analysis. So assume you have a voltmeter. Voltmeter consisting of two wires, one is positive, other one is negative. So the voltage across this one can be taken as, see, you have connected the positive red wire here, black wire here. Obviously it will read as minus 28. So similarly, if you connect like this, since there is no resistance here, here the voltage will be 0. If you connect like this is positive and this is negative, obviously it will indicates a positive voltage, but at present we don't know the actual voltage, so we are indicating a positive voltage. In the similar fashion, if you connect voltmeter in this fashion, you are also getting a positive voltage. So by using any one of the loop, you can write equation as, since we are considering the primary loop, we will write the equation as minus 28 plus 0, this is 0, plus ER2 plus ER1 is equal to 0. And then this the same analysis here, minus 28 plus ER2 plus ER1 is equal to 0. ER2 with the help of Ohm's law, I2R2, ER1 is I1R1. So since you know already R2, R1 value substituted here. In the similar fashion, go for another circuit loop which is having 7 volts battery. So connect here, it is negative, so it obviously the voltage will be negative here. So here the voltage will be 0, and if you connect here, so this is positive is connected to positive and negative is connected to negative, and the voltage is 7, so it will read 7 volts. And here the positive is connected to negative and the negative is connected to positive, the voltage will be negative. And if you write the equation for it, minus ER2 plus 0 plus 7 minus ER3 is equal to 0. Now from the first equation, Kirchhoff current law and Kirchhoff voltage law, if you solve these three equations, three unknowns, three equations, you can get simply the current I1, I2 and I3. This is a simple branch current method.